Today we will be discussing about the Liskov Substitution Principle, which is the third part of the solid principles. In solid principle, S single responsibility principles we have already explained, and open close principles we have already explained in another video. Now this video is all about Liskov Substitution Principle. What is the use of Liskov Substitution Principle, and what is the purpose of Liskov, and how it will improve our code quality, and how it will help other developers to understand this. If they comes, and then how they can understand and they can grow with this code base again with the new feature, new implementation, and all. So let's discuss about first I'll discuss. The first part I'll discuss is just nothing. It's a very small. Let me just add the file text. Yeah. So first I'll discuss what is LSP. It means substitution principle. Okay. Liskov substitution principle. So I'll explain this one. Key Liskov substitution principle is an object-oriented programming principle that the states of subclass, you can say, or child class can replace their parent class or superclass, we can say, without altering the program's correctness. What it means? It means that there is a parent class, and if parent class is there, and for that parent class there is a multiple child class, we can say child class, or we can say subclass as well. Okay, so child class, multiple child classes there. Okay, so now these classes, whatever they are extending to the parent, if parent if it got replaced, parent got replaced by child class, it means कि parents object of parent, uh, 1 minute, parent object replaced by child object, so it should not affect the correctness of program. मतलब means कि like for whatever the parent is doing, whatever the functionality of parents are there, if that is replaced by the child object, then it should not misbehave. It should not something like कि correctness of program is misbehaving. So let me have one example. So the first thing we have already explained कि LSP requires that subclasses can take on the responsibilities of their superclasses without any side effects or behavioral changes. In other words, code that works with a specific type of object should be replaceable, should also work with any of its subclasses. So parent class replaced by any child of object, it should work properly. Now let's have an example. Let's say if we have a class called animal and another class that is dog, which is inheriting the parent class, which is animal. Now then we should be able to use dog everywhere wherever animal object we are using. Getting my point? So wherever we are using animal object we are using, we can replace with the dog object, and it should not misbehave. It should work as it is, whatever it was working earlier for with the animal class. Now what is the importance of LSP? Importance of LSP is like let's say promotes reusability, modularity, maintainability, and by ensuring that components with a hierarchy can be easily interchangeable basically. Now let's some indicators of LSP violation, how it's violation. If I'll talk about violation, what is that? Okay, everything whatever I'm writing like discussing now, everything you will get in GitHub repo basically with all the documents and everything, all information will be there. So let's say violation of LSP, conditional logic in client code. Some logic we have written, conditional logic we have written in the client code basically, then it is violating basically, because unnecessary. If you are writing in the client code, it means कि whenever you will replace parent object with the child object, then the same logic you have to do with the child object as well. So it's wrong. It should be at the main level basically. Now empty implementation of method in subclasses. Let's say we have a three methods are there, which is implemented with parent. Now whenever you are extending the inheriting the child object, inheriting the parent class in the child object, then it's not like a child object should not implement those methods are just empty, they kept it. So if we will do this one, then correctness of the program, it's violating the correctness of the program. It means violating the LSP. Now the third part is very important. If any method we are not implementing, in that case, it's not like we have to throw some error and all. That is wrong. That is how LSP is there to provide this maintainability, reusability, and modularity basically of that program. I'll give everything details in the README file of this principle. Okay, let me have a example. Let me go there. So I have already written all those things. I'll just use that one. Let me go there. Okay, copy, paste. Yeah, and let me copy this one as well. Let me explain the code wise actually. We have a interface, an employee which has a get minimum and calculate bonus, and now this is the parent class basically. Now this is implemented by three different class, which is contract employee, permanent employee, and temporary employee. Let's go with the contract employee. So contract employee, if you see, it's returning some minimum amount, that's great, but for calculate bonus, contract employee doesn't have any bonus at all, so that's why it's throwing here no implementation available for this one. What about another one? If you go with the permanent employee, it has minimum salary, but it's returning some calculate bonus as well for permanent, same as temporary as well, the same things, okay? It will return the calculate bonus. But you saw the contract employee, it's throwing the error which we talked about already, ki it's a violating the LSP basically. We cannot throw any error, we cannot alter the correctness of the program. If anyone is trying to fetch this calculate bonus with the contract employee, then it should not, like, they should get the amount actually, they should get the value, calculated value, but here it's violating, right? So let me go there in test cases actually. I'll show there. 1 minute, so sorry for that. Yeah, so test cases already, all things are there. I'll just add this in the path so that it should not work. It should work properly. Okay, yeah, fine. So now we have this I have a manager class. Basically manager class is doing, it's something like, if you see here, it's returning the employee, whatever the object you will return, set here, based on that it will return the get minimum salary, get calculated salary. So it's violating the our overall things are there. If you see, this is contract employee. For the contract employee, 1 minute, it's not working. Yeah, so if we'll run this test cases, you see what we are doing here. We are just 1 minute. So we'll look at also the module source root. Okay, what is this issue, man? It's first time. 1 minute. Yeah. What is this? Okay, it's 17, I think. Yeah. Let's run this one. So here this test case passed because whenever I am providing the contract employee in our test cases, so it's trying to fetch the minimum salary, which is fine, because here if you see minimum salary, and what was the object of that object was the contract employee, so it will return the amount. But what about this one, next one? So when we try to call the calculate bonus, it will go in the manager class, and from their manager it will try to calculate the bonus for contract employee. Why? Because for contract employee I have given the object, while creating the employee manager, in constructor I send that contract employee, so here it will throw the error. So if you see, that's why it's validating. Okay, it's showing unsupported operation and all. So This test case is like done. Now permanent employee, we are trying to fetch the get minimum as well as calculate bonus. Both will work fine because we are giving them this permanent employee object basically. So here we are giving for the same I employee, we are giving object of replacing the object contract employee, permanent employee, temporary. But it's misbehaving because if you see here, for contract employee cannot go and calculate this one, right? So this is the bad design things and all. Let me go with the good one where I have written everything. Okay, where is that? Just so I'll just copy here and paste this one. So contract employee, yeah. So let's go with that. So now I employee, because now two things you saw, right? In I employee we had a both actually. We had a both basically. What's that mean? Calculate minimum, get minimum salary, calculate bonus. But these are not apply for all the employee. That's why we have to separate out get minimum salary and calculate bonus, because those are two independent things. Calculating the minimum salary for all employees it's applicable. For calculating bonus, it doesn't apply for all the employee. There is a contract, there is a like temporary, there is a permanent. Maybe for contract it's not applicable. So we should not alter our logical thinking, logical things basically for that class, right? So let's come here, and then what we did, we have just created the new get like I employee, where we removed it that get calculate bonus and we kept in the employee bonus. Now whoever need this implementation, they can go and implement this one, right? So if you see here, permanent employee need employee, I mean calculate the minimum salary as well as employee bonus they also need, right? It's correct because they can do and calculate this one. Now temporary employee also need get minimum salary as well as employee bonus, but for contract employee we see they need just get employee salary, nothing else. It's like we don't need calculate bonus and all. That's why here we have not added. Now if you see using the Liskov, we have separated out two different interfaces where the work of that interface is a different altogether. It means whoever is going to extend that interface, it's not going to break anywhere if anyone is replacing that object with another object for the same class, for that parent class basically, right? And let me just go with the test cases. So let me just run this one. Oh, 1 minute, why it's not working? Okay, what is this? Start add 17. It should work. What's that? So which is 1 minute. Yeah, let me test this one. So what is doing test employee, where I have a using, if you see, I just created the temporary like here I employee is there, which is just a single interface. For that I have just replaced with a temporary employee, and I am just trying to fetch the get minimum. It's coming. Okay, for temporary employee, for employee bonus, if you see this I employee bonus is there, I have replaced with the temporary employee, and I am able to calculate this one, right? But now here if you see the same employee I employee, I have just replaced with the permanent employee. The functionality is same. It will calculate the minimum salary but with the different value, but it's not a problem with the different value, but implementation should be same. It should act as a correctness basically. Employee bonus we just replace with the permanent employee here, and now you see with that permanent employee object we are able to call the like employee bonus. It means ki if these two methods we are calling, and we can just replace with the object, it will perfectly work. There's nothing going to break. And in contract employee we have just replaced with the contract employee for the I employee, but here we calculate any bonus and all because we don't need that. That's why we did not implement it with that, right? So this is the Liskov principle basically with the code I've explained all what is the bad design and a good design and how we can do it. And this is very important part of our solid principle and a very important part of our software design and all. So yeah, thanks guys. I'll be explaining next after this call. I'll be explaining interface segregation basically in the next video. Thank you.